All right, let's get started. I'm going to be talking about our experience in getting free technologies to work together, namely C++, Python, and JavaScript. Well, JavaScript and Python have historically been integrated using REST APIs and things like that over the web. We've done things a little bit differently for good reason, and I'll tell you a little bit about what worked and what didn't for us. So just a tiny bit of context. So my name is Paul Habfast. I'm the head of cloud services and lead engineer at NanoLive. NanoLive is this microscopy company. So we built this microscope here, which is a holotomographic microscope. I'm not going to get into too many details. Just think it's sort of like an MRI machine for cells. So typically we get images, we do a lot of processing, much the same way that MRI need a lot of processing. And then what we get are 3D images as output. This is very practical for biologists because as you've seen the images, you don't see very much. Usually cells are mostly transparent. And so because we don't measure the same way as traditional microscopy does, but we measure the speed of light, we can see a lot more details. So basically, I'm going to dive a bit more into what was going on at the company, what led us to these developments. And then I'm going to talk to you a bit about how we integrated in turn Python, C++, followed by JavaScript and C++, and then finally Python and JavaScript. It didn't all happen in one day, obviously. And then that'll allow me to dive into what worked and what caused us trouble. A bit about what's coming next, and then I'll take a question. If you have any question during the talk, don't hesitate. So about where we stood a little bit over a year ago, our technology stack was mainly C++. I mean, like only C++, to be honest, with various libraries around them. The reason is that we really need high-performance computing. We've got a microscope that needs to handle 50 megabytes per second of data, if not more. And then these need to be computed. We've got a lot of advanced processing going on, Fourier transforms and so on, so CUDA. And then for the user interface and for a few other things such as threading and we used Qt. Qt, does anyone know about it? Anyone doesn't know about it? So it's this C++ framework, and one really interesting thing about it is that it's event-driven. So it has this sort of extra syntax that is not standard C++, that parses your classes and extracts some metadata, and it knows about the functions by name and which parameters going and so on. And you can do things a bit like sort of a limited reflection on that. So what was really going on is that we had this software, and we had me trying to work on that. And then we had this guy show up. And he was the physicist working on all the theory. And he was like, I want to work on the raw data within the program. So we needed to give him a way to really work on that raw data. And then we got this guy coming in, our biologist. And he was like, oh, I want to have the microscope using scripts all remotely. So we need also to please this guy. We had this guy, our designer. He was like, I want to work on nice designs, and all your C++ stuff is really crappy. And finally, we had this guy, and he was like, you need to ship something. So that was a bit interesting. That's where we stood. So where we really started was with the Python C++ to please the two guys at the top. And so what we did is we used a library called pybind11 to expose our APIs to Python. Pybind11 is this really, I mean, if any one of you think he knows C++, go check out pybind11's code. It's like completely next level. I've never worked with a library whose code was so good. I don't think I'm the worst programmer ever, but this is beyond me. And so what you can do is you basically have this function, and then you can expose it to Python, and Python will directly call that. And so if I actually give a little demo of what this gives, so typically, if I open a PowerShell, and then I start some Python, the sort of thing that I can do is typically I can, let's say, so here what I'm doing is I'm initializing a system that connects to the microscope. And I need to initialize it so that it starts all the threading and stuff, because you need a separate thread to talk to this. And that's where typically Python has a little bit of issues. We start needing many threads to do all the rendering, all the storage. We've got files that are upwards of 1 terabyte. The microscope needs its own thread to be responsive, and so on. So this will live in its own thread. So typically does its own initialization, does a few things. Right, it moved, it's alive. And now, typically, I can do, so it's not going to be super visible, I'm sorry about this, but typically, I can do things like just turn on. You can see the light turn on, similarly turn off. And it's a really neat library, because the sort of stuff I can do is, if I import the library that's to do the storage, so here import PyStorage. Oh, you probably cannot see very much on the screen. That's really far. Let me lower the resolution a tiny bit. It's already lowered. Okay, never mind. So we'll do with that. So. No, that's not it. All right. And I load a file that I prepared beforehand. I think it's that. So I can actually load the file. And if this is our exposes our APIs, but storage dot and now what I have, so when I called this, it actually loaded the data that was inside my file. And this is just a file that's like a few hundred megabytes. So the things can get a little bit quicker thanks to this. And oops, here. So Arval is really the volume of data, three-dimensional volume of data that is stored inside the file. So now I can really start handling this data. But this doesn't mean much to anyone, especially not the physicist. What they want is to work with numpy. So what you do is I create a numpy array with this. And voila, I get an actual numpy array. And the really neat thing is that it doesn't use any extra data. It sort of wraps my binary data. And if you look, all the numbers, they're all floating point numbers with numbers around 1.33. That's because it's actually water that's inside the volume. So here, now I can actually start dealing with the data using numpy, which is what the physicists typically want to do. So, and now the other way around. So now we can call Python, our C++ from Python. Now we want to call Python from C++, so that we have two-way communication. Now, little question: how would you guys do that? What's the silliest thing that you can think of? Yes?
Cause the system executable directly from C++.
Almost. So yeah, what you do is you actually integrate the Python DLL file, and you directly embed the interpreter, and you call the interpreter and you send it strings, and it works. So I'm going to close my PowerShell, and I'm going to go back here. Instead of calling the PowerShell, I'm going to launch my program, which is the one you saw a minute ago. And I'm going to open the debugging console. So I don't need to reinitialize our system, but now, because it's been already initialized by the program itself, but now I can do 1 + 1, 2, Python. So I just send the string, and it works. So now I could do all this stuff with the storage, or I can so if I do import by system, you'll recognize a few of the commands. It's all the same stuff. Okay, so now I don't need to initialize the system. The software took care of it for me. But now if I turn on the white light, and it's on. So now I actually, from the Python, send a command to the microscope to turn on the microscope, and the images are coming back up, and the user interface answered to that. Now I can actually control things. Similarly, if I turn off the white light, I can do system.storage.load. So storage is the same storage that I had before, and I do the same file. I think. And voila, the data is here. So I was actually able to control my C++ application from the Python console, from the C++. Right? Because this thing here is C++, the console. So I send a string, several strings to the Python, which interpreted them and forwarded to the DLLs. And so I actually was able to inject in the Python the global variables of my software. Right. Where was I? All right. So now we've got two-way communication between the Python and C++. What's coming next? So what we want next is to be able to call JavaScript from C++. And that's where the Qt framework really helped us a lot. Because in the Qt framework, you have a sub-DLL that integrates a Chromium browser. So actually, we were able to just integrate Chromium browser and communicate with that Chromium browser, and we have both high and low level access. So the sort of code that we're talking about is I create a WebSocket server, and I say, oh, I want to listen to to some port. Does anyone know what the 0 port is? It says, system, just give me some port that's available. So like that, I don't need to know that the port 1234 is available or not. I know that it'll always work unless all 60,000 ports are taken. So listen to that port, and then I can inject some code. Typically, here I can inject the URL of the server that I just created, because I inject the port, and then I insert my script, and I launch my page. And so I've injected into my page the URL of the WebSocket server that I've just created. Typically, if I go back to the console that I had before, so yeah, obviously I can call, I've exposed my DLLs to Python. So now instead of doing it from the C++, it'll be just a little bit easier to script it directly and do it from, start up this from the Python. So typically, let's create something by webui dot create a new view, and let's say I want the white light, but the white light needs access to the acquisition to be able to retrieve the data. So did I do anything wrong? All right. So it's not showing up. That's because I need to actually ask it to show. There we go. It's black. OK, so it's black. It's because the white light is off. But what's really cool is that this is really Chromium. So I can debug it the same way I could using any Chrome. Think of it really as a little bit like an Electron app, except the backend is not a Node.js application. It's a C++. But so now what I can do is I can open a browser, and I can open this. And the URL is really weird for the reason that actually it's the page is packaged inside the C++ application. But nothing prevents me from actually loading any page on the internet. I could load google.ch. I could do anything. It would all just work. And now I have a proper debugging console. And I have access to everything just the same way I would want. So if I do inspect element, it's all there. I can see. And I can inspect. I can do performance monitoring, things like that. Typically, here I can see that this image should be 1024 by 1024. So typically, let's just resize. That'll be next, actually. Let's go back to the presentation. So what's coming next is to be able to invoke the C++ from the JavaScript. And again, Qt helps us because of this sort of metadata that it generates. Because that means that it knows which functions are available, which events can be sent, and so on. And then it wraps this in the shape of in the WebSockets. And so now what I do is I establish a WebSocket connection between the front end and the back end, and they can communicate, and I can expose any API I want through that. So typically, if I go back to this view, I've exposed things that allow me, for example, to resize this. So now I have control. There, resize. So a bit the same way I could do this using Electron. I have control over my page. And then I just needed to expose also the acquisition that starts the white light. And the white light is here. So now I was able to actually start them. This is a live image coming from the microscope. And because I started the white light from there, show. There we go. It actually shows on both windows. And I was able to do this from, you see here the URL is updating. And I will also just stop it. And they will both stop. Here we go. So yeah, now I'm able to actually start and stop things on the C++ from the JavaScript. This was really mostly sort of luck that we had the right framework that allowed us to do this. But if you need one day to do something where you need a little bit more performance on the back end than an Electron app would allow you, this is probably a great solution, although it will require some more work than Electron, which is all pre-packaged, even though you'll get some help from the framework. And so now, what if you want to call the JavaScript, have the JavaScript and the Python interact? Well, use a C++ as the middleman. So if I close this window, and instead, just to give you an idea. So dot views. So here. So similarly, this is just a joystick, right? Nothing special about it. It's completely generic, so I could integrate this pretty much into any project. This is just a library that I reused. And now what I can do is view.connect new position, I think. So what I'm doing, for those that don't see, I mean, it's a bit far, is I created this joystick that I showed, and then I connect to some events called new position that, based on an XY position, when I move the joystick, I will print the X and the Y. So I print this string. This is actually pure Python code. So it's really a Python lambda, and I print the format. It's all pure Python. So, and must have done a typo. I think, yeah, I forgot to close a parenthesis. Right. And so now, if I go back to here. Oh, yeah. Oops. There we go. L4. And I forgot again to close the parenthesis. We'll get there. So unfortunately, now I have the connection twice. So actually, it'll print twice, but you'll get the idea. So now, every time I move, I get the updates, which means that now I have a JavaScript view that's connected to WebSockets that is connected in C++ to some Python event handler. And whenever I move this, it gets in there, and I can actually respond to that using Python if I want to. I mean, I give a lambda, but it could be anything. Yeah. So this is roughly a high-level overview of what happened during the project development. Now, what really went well? The DevTools. So you've seen me open up the DevTools just a minute ago. It's not just the Chrome DevTools. Imagine you pretty much all know the Chrome DevTools, the Safari DevTools. I mean, we're Webmardi. I imagine, so the framework that we used to do the UI was React in combination with Redux. And they come with their own DevTools, which are actually extension to the Chrome web browser. And actually, they hook up also to your application. So I'm actually able, so I actually can't show you this because this is a demo laptop from my company. Didn't have the time to install React and Redux DevTools. But I can basically hook Redux to my application and monitor the state changes. Redux, so who knows here, who doesn't know React? Okay, who doesn't know Redux? Okay, so React is this framework to render a user interface, and Redux is this library to do state management. And so with that, I can easily check what's going on with my rendering and with my state, and then I can do everything else with the Chrome DevTools. And so all the debugging was made really easy thanks to that. Also, something that's just on the side, we target only one specific version of one Chromium. So we don't have to make sure it works in Firefox and Internet Explorer 8 and so on. That simplified also all the development. The numpy integration for Python, so that I showed you already. So this was really useful for the data analysis. You saw it. I can just open NumPy. Who here doesn't know NumPy? Right. Oh, a few people. So just in a few words, numpy is this absolute reference library for doing any sort of mathematical processing in Python. If you want to do data science, if you want to do basically anything, it's must know. Something else that worked really well is Redux Saga. So I'm going to dive a tiny bit into more details about this, but Redux Saga is this library that hooks into Redux, and the goal is to do side effect management. So typically you have side effects that you want to do when you call backend APIs, usually through REST APIs. And you want to handle user inputs and state changes and so on, and it's really made for that. So to give you a little example of what this could look like, imagine you have a backend API where you have items. The example I'm going to show you is very slight modification of a real procedure that we have in our backend, just to show you the incredible simplicity. So I want to list my registered items and then put them in my store so that it updates the store and then updates the user interface. And all I have to do is this first call. This will return a promise, a JavaScript promise. And usually what you would do is you would promise.then.catch and so on. Here I can just do this yield, and the Redux through the generator will do the behind-the-scenes work. And in the registered items here, I will get actually the result of the promise. And then I can directly put it in my store. And so this allows me to have sort of linear synchronous style code when actually everything that's going on here is completely asynchronous. And similarly, I can have add item when I call some backend APIs. Similarly, whether it was a success or not goes into the result of the promise of the backend call goes into this variable, and then I can handle whatever is going on there, and so on. So I can same thing for deleting the item, and then something to put this all together, where this initialize channel is where I initialize the connection with the backend. For any of you who have to do any sort of side effect management, typically call a backend for a login, anything, try this library if you have Redux around. It's a game changer. All right. Now for the things that worked a little bit less well, image stream performance. So we've got images coming from the camera, and they go into the backend, the C++ backend, which has high performance, and then you need to stream them 50 megabytes per second or more, 100 megabytes per second to your front end. And the problem is the JavaScript needs to be able to absorb this much data, but this takes time. And time you don't have much in the front end. So it's actually a very efficient way of killing your front end just by overloading it with data. Your WebSockets can't keep up and so on. So you sort of have to do compromises, and you start compromising one thing after the next. So first you start new threads on the back end to do image compression, and you reduce the resolution, and you reduce the frame rate, and so on. And in the end, you've got acceptable performance. And then you notice you want to debug the actual performance, and you notice that your data goes through Redux, and you completely crash the devtools, and you crash even the Chrome devtools. You crash everything because it's so much data that they're not meant. They're meant to handle just a few bytes at a time, and all of a sudden you're throwing megabytes all at once. So we had to sort of hack everything to just get the data and put it directly in the image once it's been PNG compressed and so on. We had to do PNG compression because we needed really real-time feedback. Whenever you do MPEG-4 and so on, you always get a few seconds of lag, and that was not really acceptable. Something else that really hurt us is the Qt update cycle. So, as I mentioned, Qt comes with an embedded Chromium. But the Chromium is bound to the version of Qt. So if I want a different version of Chromium, I'm stuck. And so what happens is, oh, I find a visual bug related to some CSS property that's not propagating properly, and it's clearly Chromium bug due to the fact that it's using the old version. So we upgrade Chromium. But if we want to upgrade Chromium, we need to upgrade Qt. And it so happens to be that the new version of Qt, if we want Chromium, we need to use Visual Studio 2017. We're using Visual Studio 2015. And all our other dependencies are compiled using Visual Studio 2017. So, and on Linux, they are generally binary compatible. On Windows, they're not. So basically, we're stuck. And it's like, deal with it. It's yeah, good for you. So basically, we hacked our CSS differently so that it would work. And we're stuck. And maybe in the future, we'll take the time to upgrade all our dependencies at once. And yeah. So what also was sort of ugly is Python and C++. So if I take a typical Python project, you've got your sources and you start your Python executable and directly in your project, and you have everything there in your sources directly. If I take a typical C++ project, it's the exact opposite. I've got the sources, and in a different folder, I've got my binaries. And now we need to get these two models to work together. So typically, I want to keep my C++ and Python sources together. But if I have my Python sources there, I cannot work with Python there. So I need to transfer them as I work with them to my C++ build directory. And I need to do that on a, like systematic basis. So we had to do, again, some sort of hack using Python wheels and things like that. Yeah, we ended up with some sort of monstrosity that's sort of like, with, especially with, the Python tests. So we had unit tests in Python to test our bindings. And the problem is, the Python unit tests were in the source directory, but we had to transfer them before each test to the build directory so that they would actually test the binding which are in the build directory. So that was also a little bit of a complication, but we've got something that works. Something else that didn't work so well, so the main thread. This is a non-issue for 99.9% of the people, but it also came to bite us. So if you think of the sort of hello world program, you've got your main file in which you've got main, and when you start a process, it starts a thread, and which runs in this main, and this is what's called the main thread. And in Windows application, well, any application that has like GUI, it's the same on macOS and on Linux. All user interface events are sent to that main thread, to no other thread. So you can do networking on a side thread, you can do work with the USB on a side thread, that all works fine. But the user interface needs to be on the main thread. There's no going around it. And the problem is typically when you've got the Python command line, the Python actually takes ownership of the main thread. So you can send any user interface event, it will just be frozen. The user interface will not update, nothing will happen. So that means this is actually why I've not shown you any user interface while running the Python executable. It's because it doesn't work. Now, there would be possibly a way out thanks to the way we do things, because since we're working with a Chromium browser, we could just start an actual Chrome instance, which would work with WebSockets to our backend on a separate thread. Too much work. We haven't done that. Similarly, if I'm talking about a web server, typically Django or Flask or anything like that, typically these also take ownership of the main thread. So I cannot start a Django web server from my GUI. So this is also sort of a limitation. It's either you do it headless without any user interface, or you do user interface and then you don't have any Django or yeah. Last but not least, a little bit about software architecture. You've seen it goes in every direction. So we've been pretty careful that this doesn't happen, but it's actually really easy. When you've got JavaScript, which calls C++, which calls Python, which sends back events to JavaScript, and it goes in every direction, it can easily get very messy. All right, we've done it. So what's coming next for us? Well, we've been working at it for over a year, and we still haven't shipped the next generation product that we've been working on, which is not this, but we would like to finally ship it. It's been, Scrum promotes sprints of 2 weeks and so on. It's been sprint after sprint after sprint after sprint for over 6 months now of we need to deliver quick. The whole team exhausted. Next month is the actual launch, and we're really looking forward to after the launch. We would like to try a few different things around machine learning, integrate machine learning frameworks, because of this numpy integration, we can probably also do things with TensorFlow and PyTorch where they could use directly our data without any copying. We can probably write a C++ WSGI gateway. It gets quite technical with Python, but basically we would like to try to get this sort of Django or Flask integration working while still having a user interface that could allow a few things, such as we could remotely connect to actually an instance of the application running and see what's going on through a handful of REST APIs. I haven't gone into too many details about the logging console that's here, but it's really awful, the one that's here. Typically, if you don't see, I'm clicking on the up arrow. I'm not seeing all the last commands. It's the worst command line that you've ever seen. We want to drop this and get something better. We'll probably do it in JavaScript. So once we get that done in JavaScript, that means that we actually write Python commands in the JavaScript, which then gets sent to the C++, which gets sent to the Python, which we'll get there. But